remember, this side that says remember. So today is going to be an extension. Yesterday we learned about the shape of the parabola, how you find the vertex, and I'm going to tell you, everything hinges on the vertex. If you don't remember x equals negative b over 2a, you're not going to get any problems right today. You're not. I'm going to tell you that. The other common question I had yesterday is, when you're working with that equation, a is always what's in front of the squared term. B is always what's in front of the term to the first power, and C is always the number that doesn't have a variable. It doesn't matter which order they write them in, correct? Okay, so just so you remember that. So extension, today we're going to start graphing them. Yesterday they provided us all the graphs. Today we are going to graph them. So it says find the vertex, the equation of the axis of symmetry, and the y-intercept. To find the vertex, we always start with x equals negative b over 2a. You guys got in a really good habit yesterday. Let's not stop that. What is a in this equation? 2. B is 4, and c is negative 3. Okay? X equals, what's negative b? Negative 4 over 2 times 2. So negative 4 over 4, or in other words, x equals negative 1. Now, really, though, remember, your vertex is an x comma y. All you have figured out is the negative 1. So how do I figure out the y now? Plug it in. Very good. So we're going to take 2 times negative 1 squared plus, whoopsies, 4 times negative 1 minus 3. And Mason actually made a good point. Like on a problem like this, you're writing this down, right? I know yesterday I didn't make you turn in work, but today I'm going to. I think some of you are good enough to the point that you put steps together, which I'm totally fine with. If I personally was doing this, I'd go negative 1 squared is 1 times 2 is 2. I just do it in one step. Does that make sense? 4 times negative 1, negative 4, and then minus 3. 2 minus 4 minus 3. Negative, I would agree, everybody negative 5. Okay. So my vertex occurred at negative 1, negative 5. That's a point. Okay. The second thing they asked us for was the axis of symmetry. It's an equation. What is the equation for my axis of symmetry in this problem? Bingo. It is what you used to find the vertex. X equals whatever the x is on your vertex. Number 3 is our y-intercept. We learned way long ago. What do you know? What does every y-intercept on any graph have in common? X is always 0. So if I take this equation and I plug in 0, 2 times 0 squared plus 4 times 0 minus 3, what happens? Everything cancels except the minus 3, right? So your y-intercept is at negative 3. That's why up here they said the y-intercept is always your c value, because your a term is going to have to multiply by x, which we know is 0, and your b term is going to have to multiply by x, which is 0. But c is just a constant. It's not multiplied. So technically, do you even have to show work on that? No. But just so you know why it works the way it is. Question? So you wouldn't have to show work on that. Yeah, I mean, truthfully, your work is over here, right? I mean, if you find that vertex, you're ultimately answering both in one. So this should be like, yep, we did this yesterday minus the y-intercept piece. Okay, so today now we're going to build on this. Everything hinges on your vertex. Use a table to graph y equals 3x squared plus 6x minus 4, and then we're going to state the domain and range. Number one thing you do, find your vertex. What do I use to find my vertex? Very good. X equals negative b over 2a. What is a? 3b, 6c, negative 4. Okay? So we fill it in. X equals negative 6 over 2 times 3. X equals negative 6 over 6. X equals negative 1. Now what do I do with that? I'm gonna stop for 1 second. We're gonna use the vertex here. Every single one of these problems, we have to plot 5 points. So we're gonna make an XY table with five spots in it. 1, 2, 3, 4, 5. Your vertex always goes in the middle slot. So I know my X on my vertex is negative 1. Now, yesterday we used that word symmetry. Remember that? When you draw the line, the vertical line through the vertex and fold it, the left side is going to match the right side. So in order to make sure you can double check that, and also, I can't remember who pointed out, I think it was Alyssa yesterday, pointed out in our table how those numbers started repeating, right? So on today, your vertex goes in the middle. Then you go, what's the next X value up? 0. And the next X value from there? 1. Now go the same below. 1 less, negative 2, and another 1 less. Those are the 5 points that we're going to plug into this. This is where the most common mistakes are, but if you have found your vertex correctly, you will find your own mistake. Okay? Start at the top. Let's plug in a 1. 3 times 1 squared plus 6 times 1 minus 4. 1 squared times 3. 3. 6 times 1. 6, and then minus 4. So we have 3 plus 6 minus 4. 5. So really my point, 1 comma 5 is the point I just created. So now I'm putting in 0. Probably don't have to show any work on this one. What is it? Negative 4. So our point was 0, negative 4. Now we're going to plug in negative 1. I would agree with negative 7. Did you guys get negative 7? So negative 1, negative 7. Negative 4. And then negative 3 plug in. Five. What do you notice? And it should every single time. If your vertex is right and we put it in the middle, the one above it and below it, the y value should be the same. The y value 2 above and 2 below should be the same. So sometimes people get lazy because you guys are always looking for shortcuts. They go and they calculate the 2 above and then they just fill these in. Why is it smart to recalculate down here? Yeah, you could find your mistake, right? If you recalculate it and you're like, wait a minute, this is not the same answer, you know that you got to double check something. Okay? So now we got to plot these 5 points. Remember, a parabola is a it's a nice, smooth curve. A nice, smooth U-shaped curve that does not end. So it goes down and back, oops, back up. So make sure you still have arrows on the ends. Now, it's a good thing we're doing this on Alex, right? Alex is always nicer to graph on, agreed? It's a lot smoother. Now, this is going to be like that exponential. Remember when you graphed exponential wrong and it was like, whoa, and it was all goofy? You knew right away you screwed something up. The same thing is going to happen here, and they're going to tell you you have to plug in 5, which are these 5 points here. The last part of this is the domain and range. What's my domain for this? All real numbers, all reals. What's my range? Y is greater than or equal to -7. Very good. It's above my vertex. It's above my vertex. Oh, man, there's 2 more on the back. What? What?
No, it says 2
We noticed. Let's just talk about this top one. I'll compromise with you. So find the table of values of y equals x squared plus 3. What's my a value? 1. What's my b value? Very good. And what's my c value? 3. Okay. We'll set this up the same way, but I just want to talk about what happens if your b value isn't listed there. What is it? Are you good if we don't do this one? We can skip to the bottom. You're good with that? Okay. On your own, see if you can find me the vertex. Don't do anything else. Just find the vertex, because if you screw the vertex up, the rest is a bad, bad situation. You're finding the vertex of the bottom one, right? Okay, just checking. I got 5, 5. Careful here. Whoops. Careful here. I put a -1 out there to remind myself that negative is not included in the parentheses. So 5 squared is absolutely 25, but then it's times a -1. Plus 50, which would be 25, minus 20 is 5. Anybody else get 5? Yes? Okay. So what points do I plug in now? 4 and 3, 6 and 7. Okay, you guys take 6 and 7. You guys take 3 and 4. Okay? Plugged in 7, you got 1. 1. Plugged in 6, you got 4. Plugged in 4, you got 4. And plugged in 3, you got. Is that good? That's really good. If you screw your vertex up, say you lose a negative, say this is a -5, so then you'd go -6, -7, -4, -3. These will not match. Does that make sense? So not only do you want to, when we talked about plugging in to double check, but it's also going to double check that your vertex is correct. Because your vertex being off will screw the whole thing up. Okay, so if we plot these points, domain, all reals. Every single x that you plug in there is going to work. Range, y is less than or equal to 5, right? Always your y value of your vertex. Are you going to have work today? Very much so. Okay. Grid paper in the back. Go ahead and get started.